All right, I'm going to dive right in. Stop writing JavaScript frameworks. My name is Joe Gregorio. You see my Twitter handle there. If you want to follow along in the presentation or see anything that I've got here, follow the links. It's bit.ly/zf-prezo-1. So, stop writing JavaScript frameworks. Let's start with some caveats. I am employed by Google, and this talk does not represent the opinion of Google at all. Second caveat is code that you see up here is for exposition purposes only. You'll look at it and be probably slightly appalled by a lot of it. Realize I kind of do know what I'm doing, but I cut out a lot of like the important stuff, like putting things in closures and all that good stuff, so I could fit the code on the screen. So, apologies in advance. So, first part of my talk, I am going to take some pot shots at some well-known frameworks. I'll apologize up front for that. I try to stick to mostly Google frameworks, so I think that's okay. And the remaining part of the talk is pretty simple, and I'm going to apologize in advance. You may be coming here thinking that I may do something magical or incredibly clever, and actually that's the exact opposite of what I want to show and what I want to do. Is I want to show you how simple this stuff can be and that it doesn't have to be magical. I am going to be going actually pretty quick through these slides. Hopefully we can get through all of them. I've got 130 slides, so we're going to have to move a little fast. So, stop writing JavaScript frameworks. So, over a year ago, I woke up one morning and said, I need to write a manifesto. It's always going to be a good day when you start that way. And it was there, the Zero Framework Manifesto. It got a lot of traffic. The title was slightly hyperbolic. And so the way it came out was, yes, hyperbolic. But I want to clarify there's things in that blog post I didn't say. Right? I didn't say stop innovating. I didn't say stop using JavaScript libraries. I didn't say stop using tools, and I didn't say I had all the answers, but I did want to start a conversation. So, alternate accurate titles from that blog post and this talk could have been stop using JavaScript frameworks. Really doesn't matter how many people write them, does it? Or, much, much more bland, but probably more accurate, is start writing reusable or orthogonally composable units of HTML, CSS, and JavaScript. So, I've retitled my talk, slightly less hyperbolic. So, before I go further, what do I mean by a framework? So, code that you write exists kind of on a continuum, right? Little bits of scrap here and there, right on the order of a gist. And then you get a little larger, you get a little more complex. Now you're getting up into a library, it's reusable, you've got some unit tests associated with it. At some point, you cross a line into framework. And that line is what I want to talk about. So, you're building on the web. That's HTML, CSS, and JavaScript. If your framework tries to get between you and that and introduce its own model, so here's a little snapshot of the React framework. React abstracts away the DOM from you. Okay, that for me is a red flag. So there's the, hey, let's pretend HTML doesn't exist. Or you can go even further with GWT, where we pretend HTML, CSS, and JavaScript don't exist. So this isn't good. Now, historically, if we look back, there is a reason that we got here, right? Do you remember the IE box model? Okay. If you're old enough to remember this, you will get a slight twitch right underneath your left eye. Do you remember the IE event model? That would be a twitch under the other eye. Let's not just disparage IE. Okay. If you're laughing, you do remember the layer tag. Okay, so back in the bad old days, there was no consistent model for interacting with the browser. right? It was just the Wild West. So, but that was then, right? Back then, you needed something like jQuery or something to smooth over the differences between what you were writing on the platform. The situation has improved. I never thought I'd see this day. That's SVG basic support, right? Green, across the board, last 2 versions of every browser on the planet. Browsers are improving. Evergreen browsers are just fantastic compared to where we used to be. So that, in a way, weakens one of the pillars that you stand on for a framework. For, hey, I need to use a framework to smooth over these differences between the platforms. That work can actually now be done, for the most part, almost completely, by polyfills. If you're familiar with Python, it's the import future for the web. So that future where all of these things actually work. So, but that's not the only reason people adopt frameworks, right? What about all the other benefits a framework brings? Air quotes around benefits there. Abstractions, like, okay, we'll abstract away the platform for you, right? Abstractions leak. You just cannot get away from that. This is a Stack Exchange question. Can I get that Java stack trace from GWT instead of that JavaScript thing that's happening when my code breaks? Abstractions are abstract, okay? If you have a framework and it's built this giant layer over the top of the browser, you have to learn that. This is what I call mapping the iceberg, right? First of all, just the documentation on the framework is about that 10% along the top. The other 90% is buried. God forbid you have a bug, you're going to have to go digging down there to find out where it is. And like most icebergs, that framework's eventually gonna go away, right? The iceberg melts. And you've just gathered up all this knowledge about something that's existence is actually fairly short-lived in the scheme of things. Reuse, I'd like to talk about reuse, but I'm busy porting my Dojo widgets to Backbone. If you aren't paying enough, we could talk about Angular 1 to Angular 2, but we probably won't. So at this point, I'm going to stop, taking pot shots at frameworks. It's like shooting fish in a barrel. In this case, it's one big framework fish. But you like the drawing? My daughter drew that for me. She was totally incredulous. You wanted me to draw what? All right. So, stop using frameworks. All right, I have to give you something in exchange, right? Frameworks do offer you some benefits, and that is code organization. Web components, things that can be polyfilled in, new features of the browser coming along, are the pieces you should be using for code organization. So, what are web components? HTML templates, HTML imports, custom elements, and Shadow DOM. I will not be going over Shadow DOM. We don't have that kind of time. And we actually don't need it for what I'm about to talk about. So, HTML templates. This isn't even like a future thing. It is in the Vault Working Group's living spec today, and every browser except IE supports this, and it's polyfillable. So what is it? It's a tag. It's just a tag template, which has interesting properties. Everything in there, you can put whatever you want inside that template tag. Divs, paragraphs, JavaScript, image elements, whatever. The content is parsed by the browser. It is not rendered. It is invisible to the user. They don't see it. It is invisible to everything else. So it's hidden. It's invisible to query selector. And the content is inert. If you put JavaScript in there, the JavaScript doesn't run. It's incredibly convenient. So let's take a look at some code. There is my template element. I've put a div inside of it. I can grab that template DOM element, and I access what's inside of it by the content attribute, right? Everything in there is frozen, right? It's like Han Solo, frozen solid, can't do anything. That's where you grab it, pull it out, and then do document import node to yank that into your document. And then at that point, you can do whatever you want. There, I can just append it. So let's see what that code looks like. Over here, we can pop out. And, yep. All right. What do we do? Oh, yes. So we have some content over here. This is what the code looks like. In this case, I just added a button for on-click, because I was actually wanted to show you that when you yank it out, you don't actually destroy it, right? You just stamp out a copy out of hyperspace. So cool and convenient. Next piece of web components technology are HTML imports. When you look at this the first time, you're like, oh my God, how exactly did the browser live this long without it, right? Every programming language you have has an import mechanism for modules, except how do you do import on HTML? Doesn't exist. The fact that we've gotten this far is amazing. It is oddly slightly contentious. I think Firefox claims they're not going to implement it, but it can be polyfilled, and actually their excuse for not implementing it is that it can be polyfilled. But for me, this is amazing. For code organization, you get to keep your HTML, CSS, and JavaScript all in one file, all interacting together, instead of having to break it up. Features of this. The actual imports, when you do a link rel import, the imports are deduped. So if the browser's running and it sees that URL again, it will just skip it. It knows what's there. HTML imports can contain anything, HTML, CSS, JavaScript. An important point, the scripts, when you load it loads up in its own document over on the side. In there, you could put a script tag with JavaScript. That JavaScript, though, runs in the context of the window that did the importing. So you always know where you're running from. So let's take a look at an example import.html. We already know about HTML templates, so we might as well use them. So it's my template inside my import. Document current script gives me the script tag where it lives, and then owner document gives me the document. So now I know the document that the import is at. I can grab that template object and then do the .content. We just talked about that. And then we import it, document import node, and append child. So, and that, how do you use that? All right, in this case, webcomponents.js, polyfill, that is polyfilling for HTML templates, HTML imports, and custom elements, which I'm going to talk about next. And then you simply do link rel import and href import. And we are off to the races. So there we go. There's our hello world right there. So we ran it. There's our div. And there's our body, where we just extracted that out and injected it. So this code you end up seeing a lot, right? Where you do current script owner document, you keep track of where you were executing when you started, and then you do the import of a template node. That ends up happening a lot. So let's extract that out into a tiny little object here. This is not a framework. This is 6 lines of code. So we've got a context, and then we have an import. That just makes our code a lot smaller, right? There we go. New context, and then context import T. Custom elements. You can create your own tags, all right? You've actually always been able to create your own tags. The document is, browser is accepting of that. But you couldn't hook into the activities. It's hard to do. Custom elements. Given that HTML imports were contentious, I thought it was strange. Custom elements are not contentious. All the browser vendors seem pretty much on board. In this case, I'm only talking about creating new elements. Subclassing existing elements is, I think, still up for discussion. So how do you do that? This is just bog standard JavaScript, right? Object create, and then let's use the HTML element, the DOM element, as its prototype. I can add then callbacks to that object. I can now start populating that object. In this case, there are 4 custom element lifecycle callbacks that you can add. Created callback, attached, detached, and attribute changed. I now get notified as things happen to my element. Created is obviously when it's created. Attached and detached are when it's put into or removed from the DOM tree. Attribute changes when an attribute changes. These names may actually change as the standardization process goes forward, and there may actually be new lifecycle callbacks added for other things that you may want to know, like if you are moved between a document. But you can also add any other sort of attributes you want onto your element. Add functions, add that. Here's the magic document register element. That's actually the new thing. You give it the name of what your element you want to be, and then you attach the prototype. How do you use it? It's just that simple, hello element. That created callback will get called once that element is instantiated and ready to run. So click here. There we go, there's our hello world. Inspect element, and you can see that there is our hello element. And it did run, and it did inject hello world into the DOM as a text element. All right, so that pattern you see a lot of: object create, attach all the prototype methods to it, and then document register is done a lot in code that I'm going to be doing, so I'll just wrap that up in a new function. Again, a function, not a framework. And now my definition of hello element turns out to be a little smaller, just less typing. All right, there's my created callback. So putting it all together. Those are the pieces. That's HTML imports, HTML templates, and custom elements. So what can you do with this? Let's start with a little motivating example. Simplest thing you could possibly do, here's a button. When I click that button, I want to hide the next thing in the DOM tree. When I click it again, I want to unhide the next thing in the DOM tree. So what does that look like? This is all sitting inside an HTML import. There's my template up at the top. Remember our inert content. And so inside this import, I've got both markup, the template element, and script. Inside that script, I snag the context so I know where I am, so I can always get back to that template. And then I create a new element called toggle next. I attach a created callback. When it's created, first thing I do is I grab that template and get its content and put that in as a child of myself. And then I listen for the button click. And on the button click down here, I do that thing where I look for the next thing in the DOM tree, and I either hide or show its visibility. So how do I use this? Let's back up. How do I use it? I've imported my web components. I've imported util.js, which is my little utility functions. And then I import my element, which is in an HTML import. Using it is as simple as dropping in the element, and then there's something for it to actually manipulate. So run over here, see what that looks like. Hide, show, fairly simple. All right, that bit of functionality is all wrapped up inside of there. How did this work? The way it works, the way the functionality comes about, is it's useful because of what's next in the DOM tree, right? That's kind of its function, right? It's an element, and it manipulates the next thing in the DOM tree. So this is where we go into, here's how you can use these things, web components, as the structure for your code to build larger applications. This isn't about just building individual elements, right? There are surfaces already present in the browser, attributes, events, and DOM structure that are there. They're very powerful. We've been building with them for a very long time. Now you get to use them inside your own elements. And that is how you start stringing together larger things without invoking the need for a framework. So, attributes. You could have here in your DOM markup your content attribute of ID submit. You can have your ID attribute in the DOM, same value. Or, again, any sort of, once you're into the DOM, you can have any sort of attribute, so it could be functions, other sorts of things. You can be defining attributes on your elements, or you just use the elements that exist and modify their attributes. Like I said, I hope I'm disappointing anybody. This is really simple, basic stuff, but it's incredibly powerful. And I think in some ways we've forgotten this kind of stuff exists once you get into frameworks where you want to reinvent everything. Events. Obviously, you can listen for events. The important point is you can create your own events. You can use events now to communicate, decouple the bindings between your elements. And finally, DOM structure. Simple things. Something is a parent, something is a child. You can create an element, you can have things that are children of it, right? And it's incredibly powerful. Even that's just basic HTML. There's a button element, I can put an image in it. I can put anything, well, not really anything, but lots of things inside that button element, and now I have a button that looks like blank. That's powerful. It defers the decisions about what can go in there and opens up whole new possibilities. And again, DOM structure doesn't just have to be parent-child. It can be things that, conform to certain queries. In this case, everything with class foo, which is the first 3 paragraphs, but not the last one. So let's dig in and do a little more of a detailed example. This is what I want to build. I want to build something where I've got data, US cities, and I have the data for their population, their density, and their percentage of change over, let's say, the last 5 years. And when I click on those buttons, I want to resort that. Buttons already exist in the browser, right? Unordered lists already exist in the browser. I need that little shim of functionality that does the sorting and responds to the clicks. How would I do that? All right, so I want to create an element called sort stuff. You can tell I'm really good at naming things. I want sort stuff to sort things. And notice that the buttons are its children. And in that sort stuff element, I say, where's my data target? What's the query that I'm going to run to find the thing I'm going to be sorting on? So in this case, it's sortable. And then down here in sortable, you can see ID sortable. It's just an unordered list. For each of these buttons inside, we have data-key. And that's going to tell me what attribute I'm going to be sorting on. So in this case, it's data key pop. So I'm going to be looking for data pop in the children of that sortable thing. And finally, yes, in the sortable, they all have data pop attributes. So, and you can see now I've got data key density, data key change, and then data density and data change associated with that. So what does that element definition looks like, right? New element sort stuff, we're using my new element function. I've got my created callback where I'm going to listen for clicks coming off of any of the children. Again, using DOM structure. What do I do in that click handler? First thing I do is make sure it's actually something I'm looking for. I could have gotten a click off anything else. I want to make sure it has a data set key. Then I find the element that I'm going to be sorting on. I'm going to be sorting all of its children. And then I go through standard, this is bog standard DOM manipulation stuff just for sorting. So grab out those elements, look at their attributes, and then sort them and rearrange them. So, and we're off to the races. And reload. So sorted on population, they're already sorted on population. Sort on density, and sort on percent change. So, works as advertised. So, what are the surfaces in the browser that we use to create this functionality? Sort stuff has a data target attribute that selects the element to sort, DOM structure, right? I'm doing a query selector there. The target children, the DOM structure, have data attributes that elements are sorted on. Sort stuff registers for a click, that's an event, from its children, DOM structure. The sort stuff children, DOM structure, have data attributes that determine how the children will be sorted. So only the surfaces, though, are used, right? Sort stuff doesn't care if it's a button. Sort stuff doesn't care if the thing it's pointing to is an ordered list, right? All it cares about is that they generate clicks and that they have data key attributes. Sort stuff doesn't care what the elements are found that it's going to be sorting, only that they have data key attributes. Only the surfaces are used. We can change the children of sort stuff, and we can change the children of this sort stuff data target. So Same exact thing, same sort stuff, haven't changed the code, right? Now I've got radio buttons, and it's in a table. And it works just the same. Population, density, percent change. Right? I've isolated this bit of functionality inside the element, and now I've exploded the possibilities of it by not caring and going, oh, it must be a button, right? I get all of that power that you normally get from the browser. Oh, let's roll in toggle next, all right? That's easy, stuff that in there, and all these pieces just work. Look, I changed the visibility, make that go away, right? That code doesn't, that code still works. I'm building up orthogonal components. So that's where we get. So we get a framework. Web components fill in that part. Packaging, right? Packaging is done by HTML imports. Organization, use the surfaces of the browser. Events, attributes, and DOM structure. So, summary. Instead of stop writing JavaScript frameworks, start writing reusable, orthogonally composable units of HTML, CSS, and JavaScript. So, the world is not all roses, right? This is not perfect. This is, I believe, where we should be going in web development. There are still some potholes there. Once you get into this and start using this, and actually I've been developing, me and my team have been developing apps for the past year and a half or so on top of first just raw web components and then later switching over to Polymer. One of the things you will run into is CSS scoping issues. Shadow DOM is a piece of technology to help with that. It also does some other things as far as scoping. We didn't go into that, but that's something that needs to be done. When you end up using Shadow DOM, you end up needing something like CSS variables in order to get style to go over that boundary into an element, or selectively exposing what parts of your element you want to be styled and how. And in general, better compilers for things. Polymer has a tool called Vulkan, which is used for vulcanizing HTML imports, sucking them all into one big thing, and then you can, you don't have the multiple round trips to do all the imports. And that's mostly it. Just like every presenter, I've got the obligatory I am hiring, so if you're interested. We do this every day, so write backends in Go, front ends in Polymer. So that's that. I suppose we could open it up for questions.
So coming from a background where I use frameworks that are very data heavy, MVVM, MVC, things like React, Angular, Knockout that use view models, stores, props, states, etc. What I'm seeing here is that I'm seeing a lot of data stored in the DOM. I'm seeing data that might be difficult in case you're not storing it in a central location to propagate into all the different sorts of web components that you're using. I'm not sure if you'd be using custom events for that. You got an appendix though, so maybe I'll see if you can answer that. There we go.
I did not pay him. He is not a plant. Data binding is one of the very first questions that comes up, right? It doesn't have to be part of a framework. And this is kind of one of the things I was getting at is all of this bit of functionality should be composed in orthogonal pieces. You follow that link, bit.ly underline template, that is a data template expansion, right? You handed the DOM model, you handed an object and a template object in this case, and it expands it, right? That's not magic. It's 100 lines of JavaScript code, right? That's not a framework, that's just a piece of utility code, right? And that 100 lines has a lot of functionality. You look across the top, it does URLs, just basic data replacement. The data repeat num allows you to loop over an array, sets the I so you can also get the index. Bottom one, loop over objects. So you can say data repeat O, and it's an object, and then you can get the key and the name. This is just, it's not even one-way data binding, it's one-way data stamping. At this point, it just stamps it out. After having done this for a while, at least me personally, that covers about 99% of the use case. Very infrequently do I need actual data binding, where if the model changes. And I don't think in the year and a half we've come across a case where we actually need the two-way binding between this stuff. It just doesn't come up. And that may be just me. But regardless, that's a library, not a framework. So, thank you. And the library is very easily used, right? Context, import a template. You've written a template, call expand on it, and then call append child with what you've got. And we can actually look at that code. I ended up not putting it in slides simply because I didn't know how visible it would be. This is just sitting out there in a gist, which shows you how to use it, and a license. Can I just make a request? Can everybody please put a license on their gists, please? Life would be much better if everybody did that. And here it is, the templating, right? It is, let's scroll down to the bottom. Yes, exactly 100 lines of code. Okay? Wasn't exaggerating. So there's less lines of code than there are slides in my deck, right? And it can be expanded. Looks like somebody added basic data binding and controller support, right? So you can find that out there. Again, not a framework, just a library, orthogonal pieces using the surfaces in the browser. Any other questions? Big one coming up in the back.
So your argument seems to be against DOM frameworks, not against JavaScript frameworks. And JavaScript, interestingly enough, is used to drive many other things than just the DOM. And where that is the case, it's useful to have a framework that actually abstracts the multiple UI targets, if you like. So I was wondering whether, in that case, you would reevaluate the title, perhaps?
So for, what were the cases you were saying?
Well, so we're not just seeing JavaScript executed in the browser driving the DOM, basically. So in those cases where JavaScript is driving other things on the server or in native apps, for example, it's not the DOM that's the target, it's other things. And then in those cases, a framework might be useful, if only to abstract away those different surface areas.
Well, I mean, in this case, you're looking at one. If you're looking at just JavaScript, then that's just a programming language, and we have pretty good idioms for handling large numbers of libraries and stitching them together. It doesn't necessarily mean you need a framework. That's just kind of basic code maintenance and stitching libraries together. And yeah, if you don't have a DOM, then you're not abstracting away that DOM, right? So.
Yeah, I sort of talking, I guess, with the React in mind, where React and the DOM have now been separated. So React now comes in two parts. There's React in a very sort of abstract sense, and then there's the part that connects React to the DOM, but that can also connect React to a native app or in native UI views, or to SVG, or to Canvas, or GL, or anything you want. So in that case, I mean, I think there's still value in the framework itself. A DOM just happens to be one of the targets.
Yeah, I mean, you may be able to get some value out of that, but it's, with any kind of cross-platform thing, you're going to eventually run into the leaky abstractions and the limitations of whatever that abstraction was. So in that particular case, yeah, you're moving off the browser, and so that's kind of not where I was at with this. So, all right, if there's no more questions, feel free to buttonhole me in the hallways if you have other questions. I'll be hanging around either in the hallways or sitting in the Google booth if you want to stop by and chat. Thank you very much.